Howdy, PreCal. It is Miss Kosh. I am finishing up. I'm showing you, as promised, what happens if I do these inverse functions on desmos. And so the two that we were looking at in our notes looked something like this. And so here, this was the first one. I think it was number 5 in our notes. And so here's this lovely function. We see that its domain is negative infinity to positive infinity. We see that its range goes as low as, how low does it go? It goes as low as -5. And so if I take the inverse, and desmos will let me just switch my x and my y value, y plus 2 squared minus 5. All I did is switch the x and y. This, you may notice, hopefully you realize that this is not a function. That blue graph is not a function. And so what we have to do is we're restricting the domain of the red so that the blue ends up being a function. Well, we found earlier in the previous notes that the inverse function is the square root of x plus 5. Then I have to go out of those parentheses, or outside that, and then I'm going to subtract, what was it, -2 on the outside. And so that graph, you'll notice, if I turn this one off, this graph is a function, and it is exactly, it's that piece of, see how that fits right on top? We have to restrict the domain of the original so that the inverse will be a function. As soon as they use that function notation, we have to have something that is a function. Okay, hopefully that made sense. So this one, the red had a domain of all real, but the green has a range of -2 to infinity. Okay, let's look at the other one and see if we can make sense of this. If I do y is equal to, it was -2 square root of x plus 3. Come outside that radical. I used that little arrow. -4. Here's that graph. Oh, isn't it lovely? And now if I switch, if I switch things, let's say x equals -2 square root of x plus 3. Go outside the radical with the arrow, -4. Oh, guess what did you see what I did wrong? Did anyone catch that before I did? I was like, it's not graphing. Why not? Because I put in a x where I should have put a y. Notice this one right here, they look kind of funny, but they are reflected, this is reflected over the line y equals x. So if you can see that they're kind of, that they've mirror image, you flop it over that line and there you go. This is, the black is an inverse of the purple. But if I did find what this was equal to. I said that this is y was equal to, and then in parentheses I said -1/2, come over and then open parentheses. Inside the parentheses, what did I have? X plus 4. X plus 4, and then I close the parentheses and I square it, and then I had to shift it down 3. And you'll notice that this blue one is on top of that black one, but the blue one, I use the expression, you can't grow an arm. Okay, we started with the purple, and we only have, like, if I were standing in class, I would be holding up one arm and kind of scooping it out to that side and down. And when I take the inverse, I still only have one arm to work with. So this line 3 becomes my equation, but I have to restrict the domain of that equation. Well, what did I restrict it to? I restricted it to the same thing. The domain of this number 3 is going to be the range of number 1, which was -infinity to -4. And so I have to say, I'm going to use this graph and go from -infinity to -4 so that I just get that piece of it, because I can't grow an arm. Okay, I hope that makes sense. Let me know if you have any questions, and like, subscribe, comment, and go practice. Good luck.